Hello and welcome to our demo. In this video we'll be showing you a few parts in action of our project. This includes object avoidance, self-balance, the full integration, and the web server. First off, here we are demonstrating how our object avoidance works. As we can see, when an object is detected, the robot checks its choices after backing off and then moves in the appropriate direction. In the second test, we showed that the robot could detect objects that are slightly on the side and that it could go both the right and left direction without any problems. Second part, we decided to test our PID in two different pipe sizes to see how this affects our robot and its movement along the pipe. We also decided to test it going backwards to see if it works going in both directions forwards and backwards. This was our first test, and now this is our second test in a bigger diameter to see how it affects our robot. As we can see here, the robot tends to go to the right, which means if there was no code for self-balancing, the robot would end up flipping inside the pipe. And now onto the full integration as shown. Here we can see the car moving and balancing itself at the same time, and when it detects that there is a crack, it stops to read the crack and then moves on to the next crack and does the same process. Here's another example of full integration in a different type of pipe. When the robot detects the crack, it stops moving and reads the data.
So this is our web server as we talked in the presentation. Our web server is based on Flask, and here we can see that each car have an ID, a specific ID of it, and we can see the current location of each car, and also the number of cracks, and then the details for each car. To start off, is the location is sent from the cars themselves as a post request. For the number of cracks, we have a pipeline structure with four pipes, one with 5 crack, one with 0 cracks, and one with 4 cracks, and another last one with 2 cracks. So apparently, the first car did go to the second location to discover the remaining 2 cracks. If we go into details, we can see for the first car that each crack have a crack ID which increments for all the cracks that all the cars discovered. We can see the severity for each one as well as the location of the crack. The severity The severity is sent from as a post request from our AI model after looking and analyzing at all the pictures from our cars. For our location, we can see here that it discovered 5 cracks in the first pipe and 2 cracks in the last pipe. If we go back to to car number 3, we can see that the cracks ID is still incrementing with the same order. That's why it showed there the crack ID 10 for the last pipe. And we can see that our AI model shows a difference between two categories of cracks, which are the shallow and the deep cracks. And we can also see for the third car that the locations for all these cracks are on the same pipe. And for our second car, we don't have any cracks. That's why there's no cracks detected. Thank you.